Okay, greetings for everyone. My name is Mateo Lopez, and today I will expose you about the Opamp LM741, a curious operational amplifier fabricated in this case by Texas Instrument. So let's begin with the different parameters of this chip. Okay, let's begin with the offset. This parameter makes reference to the difference between the behavior of the operational amplifier in the ideal scenario and the real behavior of the op-amp in a real test. The different physical components of a circuit has the 741 influence the electrical behavior of the op-amp. In the application, this status has an extra voltage entering in the 741 input. This voltage is having in counted to the time of design a circuit with his chip. As you can see in the datasheet of Texas Instruments, we can see a values of the voltage offset. When we go to the simulation, we can see that the gain should be 1, but in contrast, we have this output voltage, which we can appreciate the difference that we can expect in that circuit with an extra power supply corresponding to the offset voltage that we can see in the datasheet. Okay, now with the supply current and power consumption. These parameters are reference to the energy that the op-amp needs for work correctly. The power consumption is the energy used by the 741 in a period of time. This indicates how much time it takes to then prefer to drain a battery. The supply current is the flow of current needed by the 741 to work correctly. It's relatively fast to explain. The CMRR, or common mode rejection ratio, is the capacity of the op-amp to reject a common signal in their input terminals. This property is given in decibels. As you can see in these simulations, the gain in the circuit isn't effective at the circuit which have a common input. In contrast, we can see the signal amplified when we have different inputs in the both input terminals of the amplifier. Now, the PSRR, or the power supply rejection ratio. The power supply rejection ratio is a property that makes reference to the load in the supply. Well, this is a property that makes reference to the load in the supply which can be rejected without affect the output voltage. This is the relation between the changing in the supply voltage and the equivalent input voltage. This characteristic is expressed in decibels too. Now the gain. The gain, well, is the measure of the amplifier's capacity to increase the amplitude of an input signal. The gain can be expressed in decibels too, is the logarithmic relation between the input and the signal and the output signal. The supply range, this is the range of voltage which the amplifier can use for work correctly. This expresses a voltage value that refers to the maximum and minimum voltage which can use the 741, the max negative and the max positive admitted by the chip. Now the output voltage swing. As we can see, this is the range of voltage permitted by the op-amp 741. In the datasheet, we can see a maximum and minimum values. This made reference to the most negative and most positive voltage admitted by this op-amp in the output. So if a circuit with this op-amp must give a voltage higher or lower than these limits, simply in the output will not be able to give this voltage. As we can see in the simulation, the output peak voltage measured can reach the maximum value and express all the gain of 20 for this inverter configuration. Now, the max output current. Well, as their name say, this is the maximum current that we can find in the output of the amplifier 741. In this case, of get a output current in the output of if the amplifier will not have gain. This is the reason because the most common is use resistance with the order of kilo ohms for designable circuits in different configuration with this amplifier. Now the input voltage range. Well, this is the range of voltage which is admitted by the 741 at their input terminals. We can see these values in the datasheet has a minimum and maximum value, which can indicate the most negative and most positive voltage accept. In the designs of circuit, this parameter is secondary in the case of put a ground in the one of the inputs terminals, because the other terminal we have that same value of 0 to cause of the virtual short between their inputs terminals. And finally, the operational temperature. This is the ambient temperature recommended by the manufacturer to use the Opamp 741. This parameter depends on the material that the amplifier is made of. In case of a temperature higher than the recommended, could result in the failure in the correct working of the chip. In some extreme cases, the chip can get burned or part of their internal and external components molten. This is of course means the destruction total of the chip. Well, that was all. Thank you for your attention. Wash your teeth and good luck.